Alrighty, everybody, it's that time to get started with our show. I just got our okay to start, so I'm gonna put away our space trivia questions up on screen because now we're gonna be heading into the unknown. Ooh. And good afternoon, everybody. Welcome to the Morrison Planetarium. Really quickly, I just want to introduce myself. My name is Christian. I want to be your planetarium presenter. And just a heads up, I'm not just a voice coming out of the walls. I'm actually a person, and I'm standing right behind you. Hey, how's it going, everybody? Hee hee hee. Don't hurt your necks. Look forward into the dome before you. That's where the whole show's going to be. I just want to let you know that I'm here. I'm going to be your space pilot in a sense. And also want to let you know that everything that you see in purple is going to be one enormous screen thanks to help of 6 different projectors hiding throughout our planetarium dome. If you're looking for those projectors, they're hidden just below that purple glow. And I'm very excited to have y'all here because you are in for a special treat because this show is different from all the other ones that we've done here today. This one's called Tour of the Universe. And this show is completely live, which means you're going to hear my voice for the next 30 minutes. And also, what we're going to be doing, well, we're going to be starting off pretty close to the Earth, and we're going to be zooming all the way out to the very edge of the observable universe. So hopefully by the end of the show, you won't have an existential crisis of where we are in space. But I do need to forewarn you, we are pretty small in the grand scheme of things, so just a heads up. But before we get started with our show, I do have to go over some quick house rules just so that we're all on the same page and have an enjoyable time in here. There's a few of us here. First off, folks, there's no food or drinks allowed inside. If you manage to bring any snacks, make sure those are put away till the end of the show. We want to keep the theater as clean as possible. We really do appreciate your help. Also, if you happen to have any cell phones, smartwatches, tablets, anything that produces really bright white light or loud sound, now's the time to turn them off, put them away for the next 30 minutes, as these could be very distracting, not only for you, but for also the folks sitting behind you. Really takes away from the planetarium experience. And folks, if you need to exit early during our show, you're more than welcome to do so. All we ask is that you exit towards the top of the planetarium. That's where you're going to find the exits before, during, and after the show, so always make your way up the stairs, not down them. Although if you have trouble climbing the stairs, we understand the stairs are very steep. So once the show finishes, just remain seated for a little bit longer. We'll have a staff member escort you to a lower exit once the show finishes up. And last but not least, folks, this show is quite immersive thanks to our 75-foot dome above us. If at any point during the show you start to feel overwhelmed, you start to experience motion sensitivity, there's a really quick and easy trick to ground yourself. All you got to do is close your eyes, take a few big deep breaths, then your brain will remember that you're sitting in a planetarium in San Francisco and not hurtling across the universe, at least not more than the usual. Hee hee hee. But with that being said, it looks like we're ready to go. So I invite y'all to sit back, relax, gaze into the dome before you, because now we're going to start our tour of the universe. Alrighty, everybody. As I mentioned, we're going to be starting off pretty close to the Earth, but we can see the Earth and the city lights just down below, all glimmering. But we're starting off up here at this spacecraft right in front of us called the International Space Station, or the ISS for short. And a lot of people tend to ask me, hey, Christian, what is the International Space Station? I hear about it all the time in news and articles, but I don't really know what it is. Could you explain it for me? Well, of course, folks, the International Space Station is a research facility, a laboratory that orbits around our planet Earth. And they conduct so many different types of science experiments that they normally can't do closer to the Earth, which has a lot more gravity. Some of the experiments that they've conducted are things like, what happens when you try to grow plants in space? Do the plants grow the same? Do they grow differently with less gravity? What happens when you try to spark a match in space? Does the flame act the same? Does that act differently with less gravity? And one of my favorites is where they had 2 identical twins. One twin lived on Earth for about a year. The other one lived on the International Space Station for a year. After that year, they compared and contrasted the 2 twins. Turns out when you live in space for a long period of time, you tend to age a little bit slower. But not only that, you also lose a lot of muscle because you don't have gravity constantly working down on your muscles all the time. So if you plan to live in space for a long period of time, remember to exercise daily. And also, folks, the International Space Station looks really big here in our planetarium dome, but it's not that big in actuality. It's only about the size of an American football field. If you've never been to an American football game, don't worry. You can also use the entire California Academy of Sciences, the museum we're sitting in. That's about how big it is. And what's also really impressive is that this thing is going really fast. The International Space Station's traveling at a whopping 17,000 miles per hour, where it orbits once around the Earth every 90 minutes, and it experiences 16 sunrises and 16 sunsets a day. Whew, how romantic. And also, this thing looks really far away from our planet, but it's not too far either. It's only about 225 miles above the surface of our world. 225 miles, that's like going from San Francisco to Santa Barbara, a nice little road trip to get away with the family for the weekend, so not too bad. And just to let you know, folks, this is as far as we put humans out into space nowadays, only about 225 miles above our surface of our world. The reason why, well, it's pretty expensive to travel into space. First, you got to build yourself a rocket ship or buy yourself one, and those aren't affordable, at least not for me. And also, you have to account for a lot of rocket fuel. You're going to need so much rocket fuel, you got to be able to escape the Earth's gravity. So you're going to need a lot of that. Once you get your hands on that rocket fuel and spaceship, you have to account for all the food, water, all the air you're going to be breathing while you're up here in space. So that gets quite costly quite rapidly. But folks, the International Space Station is just the first stop on our tour of the universe. So now we're going to see it slowly disappear to the city lights down below. And before we lose track of the International Space Station, I'm going to add a nice little orbital path so we can see it as it slowly disappears. Alrighty, folks, we've zoomed so far out now we're able to see our entire Earth in view. And I want to let you know, folks, that the space program that I'm using here in the planetarium is something that you can go home and download if you want to give it a try. The space program that I'm using is something called OpenSpace. So if you go to your favorite search engine, type in OpenSpace Project, you'll come across the link where you can download this and you can fly through space just like how I am. But just a heads up, OpenSpace is in its beta phase, which means it's not completely finished. So we may come across a few bugs and glitches. If we do, I'll point them out. Hopefully we can look past them. And also, folks, OpenSpace uses a whole lot of processing power and information. So if you have an older computer, I wouldn't recommend downloading it. It may overwhelm it. But if you got something new or a gaming computer, give it a try. It's so much fun. And also, if you're a person like me that doesn't want to download anything, or I just don't have enough space on my computer because I never delete stuff, well, we also have another great alternative called NASA's Eyes. So if you go to your favorite search engine, type in NASA's Eyes, just like the human eyeball, and then you can go to a link. And you don't have to download anything. You can still fly through space, and it's still so much fun. So we got OpenSpace Project and NASA's Eyes. But now that we got a sense of what we're using here, let's make our way over to our nearest natural neighbor to us in space, the moon. And just to let you know, folks, we humans have been to the moon before, but that was a little while ago. That was between 1969 and 1972, thanks to NASA's 6 Apollo missions that brought a total of 12 incredibly lucky guys to walk on the surface of the moon. And they got to do a lot of fun stuff here. They got to conduct science. They got to have some fun. They got to play some golf here as well. But again, last time we sent humans to the moon was 1972, a little more than 50 years ago or so. But don't worry, folks. NASA has a new space mission in the works that's going to be sending humans to the moon in the next few years. This new mission is called Artemis. And pretty much with Artemis, NASA wants to send humans to Mars, but before we send humans deep into our solar system, we need to figure out exactly how we're going to live out here in space. So the moon is the perfect stepping stone to figure out all those logistics, how we're going to be living out here. And what's even really cool is that NASA is going to be sending the first woman to the moon, but not only that, they're also going to be sending the first person of color to the moon, but not only that, they're also going to be setting up lunar bases throughout the moon. Pretty much our technology has greatly improved in the last 50 years, so we're able to conduct a lot more science in a much more compactable, smaller way. And one place that we definitely want to set up a lunar base is the south pole of the moon. The reason why is because we found ice there, and ice is going to be very helpful for setting up bases because you can melt that ice, pass electricity through it, separate the oxygen and the hydrogen, and those are both very useful. But again, we humans should be heading to the moon in the next few years, so look out for any news about Artemis in the news. And also, folks, when we look at the moon here on Earth, sometimes the moon feels incredibly close. It feels like you can reach out your arms and touch it. But the moon is incredibly far away. It's about 240,000 miles away from the Earth. Whew, 240,000 miles. Some of the adults in this room may have a car with that many miles on it. And if you take better care of your car than I do, you could even imagine driving to the moon if you drove for about 4 months nonstop, going about 80 miles per hour, Although I wouldn't recommend it, the roads out here are poorly maintained. Hee hee hee. And from here on now, folks, we're going to need to use a more useful measuring stick because at this scale, using miles is kind of like using inches to describe the distances between cities because space is so big. So astronomers use a more convenient measurement known as light speed. And light travels at a mind-boggling speed of 187,000 miles per second. That's roughly about 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so or since, it only takes light 1.5 seconds to cross that distance at the speed of light. So that's kind of like a short pause in conversation, really fast. But at last, folks, it's time for us to leave the moon behind. So everybody say, bye-bye, moon. We'll see you later. So cute. And now, folks, we're going to be stepping into a much larger realm of our solar system because now we're going to see the moon and the Earth and their orbits as they start to slowly disappear. In fact, before we lose sight of the moon, I want to add some nice planet trails because, again, space is so big, you can easily lose stuff out here. And also, folks, on our journey today, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to computer models like OpenSpace showing us the most accurate images available to us. And now the nearest star to us, the sun, comes into view. So here comes the sun. Do-do-do-do-do. And folks, the sun is about 93 million miles away from the Earth. Whew, 93 million miles away. That is a good distance away. But in terms of speed of light, that's not too far away. So remember, we're the third rock from the sun. So 1, 2, 3, that's us right over here. 93 million miles between us and the sun. In terms of speed of light, that's not too far away. It only takes sunlight about 8.5 minutes at the speed of light to cross that distance. So only 8.5 minutes, not too bad. But now that we have a nice bird's eye view of our solar system, let's do a quick refresher and see what's here because there's a lot of good stuff. Right in the middle of our solar system, we have our star, the sun, the biggest thing. The closest planet to the sun, we've got Mercury. Then we have Venus, Earth, that's us, and then Mars. These are the rocky terrestrial planets. These are places where we can actually land a spacecraft. And then past the orbit of Mars, we have this really cool thing called our main asteroid belt. And this is what it looked like if we highlight all the asteroids in our asteroid belt. There is a lot of them. And what's really exciting, folks, is that just this Monday, 2 days ago, NASA just tested its first asteroid defense system. And pretty much what that means is that we've always, as humans, have been worried about another asteroid coming and smashing into the Earth, kind of like what we saw with the dinosaurs millions of years ago. And this is the very first time that we tested our defense system to protect us from an asteroid. Pretty much what NASA did was that they launched a probe into space, and they selected an asteroid that was safe, not going to run into us at all, and they smashed that probe into a moon of an asteroid. And they just completed that mission on Monday, and so now they're watching that asteroid to see if that nudge, that impact, changed it enough to change its course. So we're going to find out if that mission was successful in the coming days, so look out for any news about the DART program, and that just happened Monday. And then, folks, we're going to get past all those asteroids because they got me a little bit worried. And now we're going to be seeing the really large planets, the gas giants, the Jovians. We've got Jupiter, the largest of them all, right over here. And then past Jupiter, we've got Saturn, famous for its rings. And then now we have our icy gas giants. We got Uranus, the funny one, and Neptune. And of course, we can add everyone's favorite and lovable dwarf planet, Pluto. So here's the orbit of Pluto coming on screen just down below, right over there. And a lot of people don't realize that Pluto hangs out here in this outer part of our solar system called the Kuiper Belt. And you're probably wondering, what's the Kuiper Belt? I've never heard of that before. Well, folks, this is the Kuiper Belt. Yeah, there's a lot of stuff out here in the outer parts of our solar system. And you can kind of think of like the asteroid or the Kuiper Belt like a second asteroid belt. What you're mostly going to find out here are icy asteroids and short period comets. Comets that don't stray too far away from the sun. They have a nice short period. And pretty much in 2006, we found more than 400 objects out here. So that's the really cool thing about science, because as our technology gets better, our telescopes, we're able to see much smaller objects much further away. And who knows what we're going to find in the next 5-10 years as our telescopes get better. Maybe we'll find more stuff out here way out in the outer parts of our own solar system. And that just sounds so exciting. But I want to put away the Kuiper Belt because that's just a whole lot to look at. And now, folks, I'm going to be adding on screen some of the many different spacecrafts we sent out in the 1970s to explore our solar system. On screen, we have the trajectories of Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2, and the latest of them all, New Horizons, which did a quick flyby of Pluto in 2015. We can see that interaction as we fly by Pluto right now, so we can see where that trajectory intersects. And just to let you know, all these spacecrafts are all traveling fast enough to escape the sun's gravity and leave our solar system behind. But even the most distant of these robot adventurers, Voyager 1, has not traveled as far as light travels in a single day. In order for sunlight to get all the way out to the orbit of Pluto, takes sunlight about 5 hours at the speed of light. 5 hours, also not too bad. But folks, we're going to leave our planetary system behind because now we're going to be heading into interstellar space, the space between the stars. Distance now becomes so immense, it's going to take us about 5 years at the speed of light just to reach the next star system to us, the Alpha Centauri system. And I always got to do a quick fly around just to make sure I got the right star system locked in. And it looks like Alpha Centauri is going to be at the very bottom right over there. So let me swing around so we can see Alpha Centauri right in front of us. So again, we're right in the middle. That's our solar system. And then Alpha Centauri is coming on screen just down below, right over there. And again, 4 years at the speed of light to get over to the next star system to us, folks. But that doesn't really put into perspective for how long it would take us humans to travel that distance. Well, folks, if you were to get in a spaceship today, left planet Earth, made your way over to Alpha Centauri, it's going to take you about 8,500 years to cross that distance. Whew, and that's just a one-way trip. But folks, let's stop and consider whether our signals have been, let's stop and consider whether humanity's influences have been made, because now we're going to be stepping inside something called the radiosphere. And again, folks, we're now inside something called the radiosphere, and this pretty much represents the current limits of the most distant radio signals humanity has ever broadcasted, or rather leaked into space. And it extends about 90 light years in all directions, emitting out from the Earth. Now, this first began in the early 1930s with strong radio waves, early television, radar signal, and then later, the detonation of atomic weapons. All this stuff is emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. And humans were broadcasting well before that, but all the earlier radios broadcasts were not quite powerful enough to escape the Earth. And since all these signals are electromagnetic, they are traveling at the speed of light, so this is kind of like humanity's electromagnetic footprint in the universe. And of course, the radiosphere is always expanding at the rate of 1 light year per year, so is anybody out there listening? And right now, folks, I'm going to be adding many markers onto the screen. These markers indicate some of the many thousands of stars astronomers have discovered over the last 30 years, which has at least one or more planets orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth-like with conditions suitable for life as we know it. So far today, we found 5,000 confirmed exoplanets just in the nearby vicinity to us, 5,000 other worlds besides our own. And that 5,000 number is going to be increasing as the years continue because as our space telescopes continue to scan the night sky, they're finding a whole heap of exoplanets. So if you look towards the top left of our screen, you can see that we just looked in this one sliver of the night sky, and we found so many exoplanets just in that one direction. So again, as they continue scanning, they're going to be finding exoplanets left and right, and that 5,000 number is going to be increasing. And again, we're looking for any of them that are Earth-like with conditions suitable for life as we know it. And unfortunately, we're not able to answer that question quite yet because pretty much we need to create new telescopes to answer that question. So they need to go through drawing boards, conceptualization, then they need to be built and then launched into space. So we've got a little while before we can answer that question. But the more important point here is that quite a few of these planetary systems are within the 90 light year limit of our radiosphere and could have potentially received our signals. However, since radio waves travel at the speed of light, if there is anybody that's out there able to listen in and answer back, the communication delays between hellos could be decades in time. Now, to give you an example, let's see. Now, to give you an example, let's say we live in a star system, let's say this one right over here, and we find an alien civilization, let's say somewhere over here on the right-hand side. We shoot them a text message, we say, hey, we live here, it takes 60 years to get to them. They listen in, answer back, another 60 years for that message to reach us. Folks, that is a 120-year conversation in the making. Whew, and I can barely wait for a text message from my friend. But of course, planetary systems beyond the radiosphere, more than 90 light years away, have not heard from us yet, but eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. And for now, folks, I'm going to put away our exoplanet markers, but I want to leave our radiosphere up on screen, because as huge as humanity's electromagnetic footprint is, it is nothing compared to our Milky Way Galaxy. So keep your eyes on that radiosphere as we continue zooming out. Alrighty, everybody, we've zoomed so far out now that we're looking down at our entire Milky Way galaxy, the galaxy that we live in. And I've got to ask, can anybody see their house from here? Just kidding, we're way too far away. And also, folks, I want to let you know that our Milky Way galaxy is incredibly large. If you wanted to cross it from one side to the other, it's going to take you about 130,000 years at the speed of light just to cross it one way. That is enormous. And not only that, our Milky Way galaxy is so huge, we estimate that there's at least 300 billion stars in our galaxy. If our recent discovery of so many exoplanets just within our small neighborhood within this vast star city is any indication, there could be billions of planets and potentially millions of Earth-like planets throughout our single galaxy. And before we leave our Milky Way galaxy, I want to show you what it looks like from a sideways perspective. You're going to notice that we live in a large, flat spiral disk of the Milky Way. And this is important because when you've probably looked up in the night sky, you probably heard someone say, hey, look, you can see the Milky Way from here. What they're talking about is this, the plane of our Milky Way disk. That's what you're seeing up in the night sky. And again, this is important because when astronomers and scientists want to learn about the universe, it's so much more easier for them to point their telescopes galactically north and galactically south instead of looking through the plane of the Milky Way galaxy, which has stars, planets, gas, debris, things that block their view of the universe. So keep that in mind. We like to point our telescopes galactically north and galactically south. It's a lot easier to see stuff. But folks, the Milky Way galaxy is only one of many, hundreds of billions of galaxies that comprise the known universe. So in this giant leap, every single point of light that you're now going to see no longer represents a star, but rather the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps trillions of stars. And we live in a local galaxy group which contains about 30 galaxies, large and small. Also includes the nearest large spiral to us, the Andromeda Galaxy. Only 2 million light years away, just next door, and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And as we continue zooming out, folks, you're now going to realize that galaxies are not evenly distributed throughout space. Instead, galaxies like to clump together in large groups and clusters, or they like to avoid each other where there's very few galaxies or no galaxies at all. So we can see a nice galaxy cluster right over here on the top right. We can see some galaxy clustering over here on the bottom as well. We can see very few galaxies towards the top or no galaxies at all. You can kind of think of galaxies like people. They like to hang out together or they like to avoid each other. And folks, we've zoomed so far out now that this picture that we're looking at represents the closest 30,000 galaxies to us over a space 300 million light years across. We got to give thanks to an amazing astronomer by the name of Dr. Brent Tully, where him and his team at the University of Hawaii compiled this amazing representation thanks to the work of other astronomers working beside him over decades of time. So big shout out to Dr. Brent Tully. I love flying through this map. But now, folks, we have automated systems that are mapping even the most distant galaxies. So now we're going to see the very large-scale structure of the universe. And remember, folks, every single point of light that you're seeing, that's not a star, that's an individual galaxy. Whew, I feel small. And just to remind you, the universe is not in the shape of a bow tie or a butterfly. Remember when we just saw the Milky Way Galaxy and we live in a flat spiral disk? Well, if we were to line up our Milky Way Galaxy as we swing around, you're going to notice that our Milky Way would line up right down the middle, up and down, just like so right here. So it would be lined up just like so. And again, we like to point our telescopes galactically north and galactically south instead of looking to the plane of the Milky Way, which has planets, stars, and gas debris. But scientists still want to make sure that there was galaxies through the plane of the Milky Way. So we have this nice purple survey right here. They were still able to find galaxies, just not as many and not as far. Pretty much we have to wait for our technology to improve, and once that happens, we'll be able to map out all these areas that haven't been filled in yet. So it's just a matter of time. But folks, it looks like we're running drastically low on our tour of the universe, so we got to press on because we have a little bit more to go. And now we're going to be encountering these really distant, faraway objects known as the quasars at the very edge of the large-scale structure of the universe. The quasars are going to be represented in these nice orange dots on the left and right-hand side. So we can see the quasars coming on in, folks. And the quasars are short for quasi-stellar radio sources. These blazing objects are all billions of light years away. So now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe. And before there was a teenager, there was a baby. So let's press back to a time before quasars, before planets, stars, and even galaxies began to form. Folks, we're about to see the very edge of the observable universe. Alrighty, folks, here we are at the very edge of the observable universe, and what we're looking at is something called the Cosmic Microwave Background Image, or the CMB Image for short. And all evidence indicates that the universe that we live in is about 13.8 billion years old. And this is data compiled by Planck and other radio telescopes. And the picture that we're looking at is a very baby version of the universe, only 380,000 years after the Big Bang occurred, where space and time began. And this isn't a typical photo either. Instead, this is a temperature density image, where the light echoes of the Big Bang are color-coded, where the lighter areas correspond to the hottest, least dense regions, and the darker areas, the coolest, densest regions. These fluctuations in temperature and density are extremely tiny. They vary no more than 1 part per 100,000. But these really tiny differences eventually gave rise to that large-scale structure of the universe that we saw moments ago, that clumping and clustering of galaxies everywhere. Figuring out just how that happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. But folks, we've traveled as far back as the law of physics can physically allow us to go, so we only have one direction left to go, and that's going to be back towards planet Earth. So let's find a nice entry point through all these quasars and galaxies. And this looks like a nice point. And let's make our return trip back to planet Earth, y'all. Alrighty, everybody, we're crossing an expanse of over 13 billion light years. We present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. And we live in a golden age of astronomy with new generations of telescopes and spacecrafts that are extending the reach of our eyes and preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. And with that thought, I want to remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of our universe. All you need is the night sky, and if you can, get away from the city lights and look up. Even a good pair of binoculars makes for a decent first telescope, and there's astronomy clubs all around the world that invite people just like you to look through their telescopes and peer into the great beyond, allowing you to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But hey, look at that. We made our way through our Milky Way Galaxy. We made our way right into that radiosphere. And now we're heading for our star system, our solar system. And now folks are about to pass those spacecrafts we sent in the 1970s to explore that solar system, passing the orbit of Pluto and the Kuiper Belt, and making our way to the third rock from the sun, our homeworld, planet Earth. All the people that we know and love, all the people we've ever learned in history, all lived on this one planet. And it looks like we're about to pass the orbit of the moon, the furthest we've ever sent humans out into outer space. And as we make our final approach back to planet Earth, folks, this is going to be the end of our Tour of the Universe show. And I want to thank y'all for stopping by and watching it with me today. I hope you did enjoy it. But hey, look at that. We made it back safe and sound to planet Earth just in time for dinner. And thank you all for stopping by. And I hope you all have a great rest of your day. Take care.